All right, welcome to Networkers Champ YouTube channel. And today we are going to talk about the interview question and answer on the TCP/IP. Okay, so these are the topics listed here. We would walk you through the TCP header as in what all question they ask from TCP header. There are other questions, the interview questions from the TCP flags as well as feature and then the UDP. So trust me, this basically video would be very useful for the freshers as well as for the experienced because I am going to cover everything in this. So it is, I would say, and I can promise if you go through this video and understand, right, you would be able to crack any interviews if they ask the question from the TCP IP. Okay, so let's get started. The first question they ask actually what is TCP and at which layer it works. Okay, so the transmission control protocol works at transport layer, layer 4, and it is significantly used in data transmission, right? So this basically protocol, right, works at the transport layer, right? That's pretty much a common question answer, right? They ask actually in interview, they ask, okay, explain the TCP header. What are the fields in the TCP header, right? So you should answer this way, right? So because the TCP actually, it is a connection oriented and it basically forms the, session before sending the data, right? So the TCP has actually, so this is basically the header what you see. We have source port here, then we have destination port, sequence number, it has the acknowledgement number, right? Reserve, and it has the flags value also, window, and then the checksum and urgent pointer, right? And then the other options as well. So this basically you have to keep it in mind that okay, these are the fields. And by the way, when when you open the Wireshark also, right, and when you see the TCP header, you would see all that details. And I think I have put that details, the Wireshark, here we go, uh, here itself. So you see this transmission control protocol. So it has the source port number, right? And the destination port. It has the sequence number. It has the acknowledgement number, right? And then what else? The sequence number, acknowledgement number, and other details which I would talk about in a moment. But yeah, this is the answer of if they ask explain TCP header. Okay. They ask actually what is TCP windowing. Have you heard of TCP windowing? And from the TCP windowing, there could be couple of more leading question that they ask, follow-up question. So the TCP windowing, it is a 16-bit window, okay, field, specifies how many bytes the receiver is willing to receive, okay, and it is used so the receiver can tell the sender that it would like to receive more data than what it is currently receiving. So I hope you guys are aware of how TCP transmission happens, right? That the two machine basically when they want to exchange the data, right? Uh, Initially they would actually build a three-way handshake. That's another question that I have put it here. What is the three-way handshakes? We'll talk about if you don't know. But let's say after three-way handshakes, a session is established, right? And this is sender and this is receiver, right? So what happens if, let's say by default, right, the default window size is 64,000. I have put it somewhere here. The default, yeah, 65,000 bytes. This is the default window, TCP window size. Okay, 65,535 bytes, which is equal to 64 kilobytes, right? That is the default. So what happens? this machine would send the first segment, first data, okay, with this, let's say 64 kilobytes, right? Data. Now, what if the receiver is more capable to, accept more data, or it is busy and it is not able to receive that much data, right? So the receiver can set a window size equal to whatever value that this receiver can accept, or whether it is more or it is less. Okay. So on basically, so basically, usually the window size is set by the receiver that, okay, I want you to process this much data, and after once this much data has been delivered to me, I will send you the acknowledgement, right? And that is the reason actually they set the window size so that the less number of acknowledgement is sent. Otherwise, every segment will have the acknowledgement, right? So that is the receiver window size, receiver window. Yes, the sender also sets the window size that I told you, right? It is the default window size if receiver is not setting up any. So when once the sender sends the window size, let's say the data, and saying, okay, I'm going to send you this much data, right? Receiver receives it, and then later it can request, okay, can you send me this much data? So let's say, for example, let's say the sender has set 1,000 bytes, okay? The receiver says, no, I don't want 1,000 bytes. Next time onwards, you send me, let's say, 30,000 bytes, okay? 30,000 bytes to me. So what sender would do, it would send 30,000 bytes data, and then receiver will send an acknowledgement that I have received it. Sometimes window size 0. Let's say if the receiver is overloaded and it cannot process any data, so the receiver can say, okay, window size 0. What does this is another this can be another follow-up question. What does that window size 0 means? The window size 0 means the receiver is requesting sender not to send any data because this receiver is exhausted. Okay, so these are a few tricky questions that they ask, as in what is the TCP windowing, and then what is the default window size, what is the receiver window size, what is the window size 0 means. Can sender also set the window size? So yes, so that's the answer. Okay. The next question, one, two, okay, four, three. So there are some different this mismatch in the numbering, but anyways, explain TCP flags. They ask this question a lot. Okay, that explain TCP flag. So these are actually the TCP flag that you see. Where it is there, you see that in the TCP header we have flags field. Okay, and if you open this flag, right, you would see these options. It will have the acknowledgement. Acknowledgement is used basically for the acknowledgement like the data has been received, right? And then you have push flag. This is the push function. This tells an application that the data should be transmitted immediately and that we don't want to wait to fill the entire TCP segment. So if basically data has to be processed immediately, then the flag push, you see that this is the push, right? Which is not set by default, it is not set, but you can set the push actually flag to indicate that this has to be processed immediately. Then you have RST, which is reset actually. So this resets the connection. So let's say TCP packet is SYN packet is sent, right? And then receiver, if it is not recognizing that TCP SYN packet, it can send a reset that, okay, can you reset the connection and send it to me again? So when you receive this, you have to terminate the connection. Even the existing connection also, you can terminate right away, right? This is only used when there are unrecoverable errors and it's not a normal way to finish the TCP connection. See, TCP connection, once these two machines set the TCP connection, why? Because they have to process the data. let's say this sender has a data to send it, right? That is why TCP connection is established. So ultimately, when the all data is transferred, then what you should accept is fin. Fin means okay, this finish bit is used to end the TCP connection. This is the right way to finish the data TCP connection. That okay, I have sent all the data. Now I am sending a fin flag. That means, right, this flag, that means I would set it to set. This flag means the data has been successfully completed and now we are good to close the session. But the reset is that forcefully you have to reset. Maybe some errors are unrecoverable, or maybe you are trying to establish the TCP session like connection using the three-way handshake. You send SYN packet, and then this guy is not recognizing. This usually happens, or this guy is expecting the IP SYN packet from the different IP address, right? That time it may send the reset. Okay. Then SYN we have just talked about. SYN packet is used basically for initial three-way handshake. So before sending the data, there is a three-way handshake that takes place, right? So the SYN packet would be sent. Urgent pointer you have seen here. This is the urgent pointer, not the part of flag actually. But when this bit is set, the data should be treated as priority over other data. Okay, so if any data which has the urgent pointer set, which is here urgent, right, which is not set by default, uh, it basically means that this has to be treated on priority. Okay, so these are pretty much the TCP, basically five flags, 1, 2, 3, 4, 5 flags, right? Now there could be leading question. Okay, what are the flags used in the three-way handshake? Okay, so what do you think? What are the flags should be used in the three-way handshake, right? So I think I would say the SYN packet, okay, and then the acknowledgement. These are the two flag which are being used for the three-way handshake. SYN packet and SYN plus acknowledgement and final acknowledgement. So the acknowledgement and SYN. That's the answer of if someone asks what are the flags involved in the TCP three-way handshake. Cool. Let's move to another question. What is the default TCP window size? Right? This is also the maximum. Just remember. So the default TCP window size is typically considered to this 65,535 bytes, as this is the maximum value allowed by the 2-byte field in the TCP header, right? You cannot actually send more than this. You cannot send the data more than 65,535 in one segment, in one go. Okay, so a receiver would never set the window size more than that. Just remember. This could be another leading question as well, right? However, modern operating system often utilize TCP window scaling. Okay, so when they ask this question, they may ask also what is TCP window scaling, right? So to effectively increase the limit significantly depending on the network conditions, right? So using the TCP window scaling, we can still increase the TCP window size from this to more than that. Okay, but again, uh, this needs to be asked. So if you are giving the an interview on this particular topic, they may ask this question also: what is TCP window scaling? As soon as you say this, right? So they may ask, is there any way to increase it, right? So yes, there is a way using the TCP window scaling. They Another question, that interesting question that they ask, okay, can you explain what is three-way handshake? TCP three-way handshake, right? So TCP three-way handshake, as you see, as I told you, uh, whenever the client, right, or the machine has to send the data, right, to the receiver. So let's say this becomes sender or this becomes receiver. In this case, let's say this is client or server, anything, right? So before transmitting it to the destination anything, they they form a three-way handshake. They go through the three-way handshake process to establish the connection. So in the first packet, they send the SYN packet. SYN is the full form is synchronize. SYN packet, okay, with the sequence number, let's say 100, right? When server receives SYN packet, server knows that okay, this client wants to initiate a data transfer. Hence, let me send the SYN acknowledge my SYN packet, right? And then the acknowledgement. Usually, what is there in the SYN packet? In SYN packet, it is like the vendor type, what vendor I am, right? What is how much data I have, right? What is the speed that I'm going to use? All those, settings, all those information would be there in SYN. And then server also would send its own SYN stating that, okay, how much data I can accept and what is what vendor I am, what operating system and all that, all those details would be sent in the from by the server or the destination. And then acknowledgement is the acknowledgement of this SYN packet, right? And you see that sequence number here, it's its own sequence number and then acknowledgement 101. So the sequence number was 100. When server replies, it is replying with the 101, one step, just incrementing of one, right? When it receives basically the TC SYN and acknowledgement, the final message, which is the acknowledgement again, right? Acknowledgement of 201. So this acknowledgement and SYN, there is a correlation. Just remember one thing. Whatever sequence number you have received, you would reply of that sequence number. So for example, here you have received, the server received sequence number 100, so reply would be 101. Here, this client has received the sequence number from the server as in 200, so it will send an acknowledgement as in 201, right? This is the final acknowledgement that, okay, I've received your SYN packet and now we are good to establish this connection, and this is where this connection gets established. And now the data transmission will start. So this is basically the TCP three-way handshake process. Another question that they ask, what is TCP hop open session? And it is widely asked question. Okay. They ask actually to know whether you have understanding on the TCP or not. So what happens, let's say when this client sends the TCP SYN packet, right? And then server sends the, SYN packet and acknowledgement. Now, this client does not send this final acknowledgement. Okay, this client does not send this final acknowledgement, and but the server is waiting. So ultimately this basically situation is a TCP hop open session. Now these basically scenario are usually used in the denial of service attack, DOS attack, okay, where the attacker wants to, let's say, send burst the millions of packets, to impact. So what they do, usually they would send a SYN packet. You would think that, okay, someone is trying to, establish the three-way handshake. You will send an acknowledgement and it your own SYN. And then server has that opens, instead of sending the acknowledgement, it would generate the burst of packet, millions of packets, right, to make to the impact. And so that is basically the three-way TCP hop open session, right? So that's what it is written here. Just you can pause this video and then go through it. Cool. Another question that they ask actually, what is the difference between TCP and UDP? So I have jotted down here the main points, right? So as a type of service, it is connection oriented protocol, and this is connectionless protocol one, right? Reliability wise, TCP is more reliable, right? As it guarantees the delivery of data to the destination because it has the acknowledgement before transmitting it, it creates the three-way handshake. But the delivery of the data to the destination cannot be guaranteed in UDP because there is no acknowledgement, right? Error checking mechanism, yes, in TCP we have, it provides extensive error checking. And though the UDP also has the basic error checking, acknowledgement, right? So acknowledgement segment is present here. So in TCP, the acknowledgement is sent once the data is received, but in UDP there is no acknowledgement. Sequence, there is a sequence numbers in TCP, data is transferred with the sequence number. This now we have seen. There is no sequencing of data in UDP. Okay. Retransmission. So retransmission, if packet is lost, let's say sender is sending the packet and due to network congestion and all the packet is lost, right? Receiver would send an acknowledgement. The previous received sequence number, it will send an acknowledgement, and this is where the sender would retransmit, right, that packet. But in UDP, there is no retransmission available. Header length, TCP is 20 bytes and UDP 8 bytes. Okay, handshaking techniques. Yes, three-way handshake supports TCP, uses the SYN acknowledgement and SYNAC, right? And then finally, the UDP does not. So it's connectionless and it doesn't make any session before sending the data. Protocols used usually. So in TCP, like HTTP, HTTPS, FTP, SMTP, Telnet, and SSH, these are the protocols used. UDP uses DNS, DHCP, TFTP and SNMP, and usually TCP is used for data transmission, where the UDP is used for voice and video, usually voice and video, because in voice and video you do not need any of these features. You need the quick transfer of the data. You don't need the acknowledgement, right? You don't need the sequencing. So wherever you need the faster communication, you would use, by the way, the UDP, right? So, yeah, I think that's it on this particular video. And thank you for watching, and please do subscribe and like this button. In case if you're looking for another, some other topics video, please do comment also. We would be happy to release the new recording. But there are many recordings that we are recording. There are in YouTube channel, right? Please do subscribe to get the latest update. Thank you for watching.